into today. So for example, if I have 1/3 plus 1/3, I will keep my denominator. My denominator is not going to change. It will stay a 3. So I can go ahead and bring that over here. The only reason I can add these together is because my denominators are the same. If they were different, I would have to do other work in order to make them the same. So now I'm going to take 1 plus 1, which is 2. So the answer for that is 2/3. Do not try to take these two and add them together and say it is 2/6. That is not how that works with adding and subtracting. So next, let's say I have 1/4 plus 1/4. My denominators are the same. I keep them. Then I take my numerators, 1 plus 1, add them together, and I get 2. So 2/4. So now I want you to try 1/5 plus 1/5. Get that set up. Think about who you need to keep, who you need to add. It should be that you kept your denominator a 5, and you take 1 plus 1 equals 2, so you should have gotten 2/5. Now let's say I have a problem like this. 1/4 plus 1/3 plus 1/4 plus 1/3. I cannot take these and add them together. I need to take the ones with the like denominators. So 1/4 plus 1/4 will be 2/4. And then 1/3 plus 1/3 will be 2/3. I cannot add these together because my denominators are not the same at the moment, and that is what we are going to go into today. But we are going to be using modeling, so be prepared for that. Next slide, it says that we are going to rename the fraction. We are going to simplify it. The way I like to simplify is I like to take these and find my factors. I can do 1 times 2 to equal 2. I can't do anything else, so I'll move to my denominator, which is 4. I can do 1 times 4. I can do 2 times 2. And then you want to find your GCF, which is your greatest common factor. They both have a 1 in common. They both have a 2 in common, but 2 is my biggest common factor, my greatest common factor. So I box in my 2. I circle my partner, and my partners are my answer. So let's try another one. Let's do 3/6. I can do 1 times 3 to equal 3. I can do 1 times 6. I can do 2 times 3. They both have a 1 in common. They both have a 3 in common. But I need the greatest common factor, which is 3. So I box in my 3's for my numerator and denominator. And I circle my partners, and my partners are my answer. They're calling this rename the fractions. This is also referred to as simplifying the fractions. You do need to make sure that you are in the simplest form at the end every time. All right, let's go to the next one. We are going to add fractions with unlike units using the strategy of creating equivalent fractions. I am going to skip the application problem for today, and I'm going to move on to our concept development. So let's say we have 1 adult plus 3 adults. How many adults would we say that we actually have? you should say that we have 4 adults. Oops, misspelling. So now 1/5 plus 3/5. Our units are the same, just like our adult units are the same. So I can take my numbers 1 and 3 and add those together and say that I have 4/5. Now we have 1 child and 3 adults. I cannot add these together because my units are different. I have child and I have adults. So that stays exactly like this. All we can say is that we have 1 child plus 1 adult because our units are not the same. All right, let's go here to 1/2 plus 1/4. We are going to be working with modeling, so make sure you're drawing your models big enough. Don't draw them like too big, but make sure it's big enough that you can work with it. You might make mistakes. You might have to erase along the way. Follow along and pause as you need to. So first we are going to work with 1/2. So I'm going to come over here and I'm going to draw a box. Let me actually find my shapes here. I'm going to draw a box. And I have 1, but I want to cut it into 1/2. Or 2 parts, I guess to say. My denominator is 2, so I want to cut it into 2 parts. Now, my numerator is 1, so I want to take this and I want to shade in 1 of the 2 parts. So that's all I'm going to do at the moment for that model. We're going to come over here and show that we're going to add these together, and we will draw our next model. With my fraction, my numerator is how many parts I am shading. My denominator is how many parts that I will have total. So for example, on 1/4, I will have a total of 4 parts. So for me, I'm going to come here and cut it in half and cut those halves in half. And that will give me 4 parts. My numerator here is a 1, so that tells me I'm going to shade in 1 out of those 4 parts. So now, all we have at the moment is everything set up together just like our equation is here. I cannot add these together yet because our denominators are different or our units are different. I have 2 and 4, or I can say halves and fourths. So my units are different, so I cannot add these together at the moment. The way we are going to do this is I am now going to come to this model. For this one, I went up and down. They'll show you go up and down, and this one goes side. I just like to keep them one direction and then change it the opposite way. So we have a half going this direction. Now we are going to take our half and we are going to split it into 4s going the other direction. So I'm going to cut it in half, and I can cut the halves in half so that I now have 1, 2, 3, 4 sections going horizontally, and I have 2 sections going vertically. Now I'm going to do the same thing to here. This is 1/4, so I want to use the other denominator, which is 2, and go the opposite direction, and I'm going to cut that into 2 parts. So now if I look here at my models, I have 1, 2, 3, 4, 5, 6, 7, 8 parts. 1, 2, 3, 4, 5, 6, 7, 8 parts. So I have a total of 8 parts for both of them, which is my denominator. For my first model here, I have a total of 4 shaded in. For this model here, I have a total of 2 shaded in. Now I can add those together. My denominator stays the same. My numerator is 4 plus 2, so 6/8. We do need to be in the habit of checking this and seeing if I can simplify. So I'm going to take my 6/8 and I'm going to come out here and say for my factors, I can do 1 times 6. I can do 2 times 3. I would go in order with this just like I've shown you in the past when we're working with factors for numbers. I would start with 1, see if you can multiply something to get that, then move on to 2 and do the same thing. Next, for 8, I can do 1 times 8. I can do 2 times 4. I want my GCF, my greatest common factor, so I would come through here and say they both have a 1. They both have a 2. The biggest out of both of those is our 2. So we will box in our GCF, which is 2. We will circle the partners that belong with that 2, and that equals 3/4. So I can say that this equals 6/8. It also equals 3/4. So make sure you have all that set up. If you did not understand what was going on, I would probably kind of go back to the beginning of this problem and watch it again so that you understand what is happening. The reason we do these models is so that we can show what is happening and how we can get them to have the same denominators. Because with adding and subtracting, your denominators, which is your bottom number, they must be the same in order for you to add and subtract. I cannot come here and say 1/2 equals 2/6. That does not work that way with adding and subtracting with fractions. My denominators have to be the same in order for me to add or subtract. All right, let's move on to the second one. I have 1/3, so I'm going to come up here and set up my 1/3. I need a total of 3 parts because of my denominator, so I'm going to cut this into 3 parts. And I need a total of 1 shaded in because of my numerator, so I'm going to shade in 1. That's all I'm going to do with that one for now. Then I'm going to come here and create my other fraction. I can even make a note and I can say this is my 1/3. And this is my 1/2. I need a total of 2 parts because my denominator is 2. So I have 2 parts. And I need a total of 1 shaded in because my numerator is 1. If you need to, pause the video so that you can finish making your models. The next thing I want to do is I'm going to look at the opposite side. My denominator here was a 3, so I'm going to use my 2 over here. And I'm going to take my 2 and I'm going to cut my model the opposite direction. We went top to bottom here. Now I'm going to go left to right, and I'm going to cut that into 2 parts. So if I look here, I've got 1, 2. That's my 2 parts. And 3, 4, 5, 6. So when I do the same to the other model, I should end up with a total of 6 parts as well. So my denominator here is a 2. So I want to look at the opposite denominator, which is a 3, and I'm going to cut this into 3 parts going the opposite direction. So I should have 1, 2, 3, 4, 5, 6. They both have 6 parts, so my denominator is 6. My 1/3 ended up changing to 2/6 because I have a total of 2 shaded in out of 6. And my 1/2 will change to 3/6 because I have a total of 1, 2, 3 shaded in out of 6. Now that my denominators are both 6, they are the same, I can go ahead and add my fractions together. Remember, we do not add our denominators. We made them the same for a reason. If I could add them together, I would have done this and I wouldn't have had to worry about the models. So I keep my denominator, I take my numerators, 2 plus 3, add those together, and I get 5/6. Because these two are one away from each other, 5 and 6 are just one away from each other, that gives me a hint that I can't simplify, but I am going to have you test out simplifying all the time, except for one case, and I'll tell you, explain that to you. But I can do 1 times 5 to equal 5. I can do 1 times 6. I can do 2 times 3. The only number that they have in common is a 1. If 1 is the only number they have in common, it cannot be simplified. If you do try to simplify it, if you say box in RGCF, circle my partners, you will notice that your partners stay 5/6. So it stays the same thing. The other time that I can tell that I cannot simplify, for example, 1/3, I cannot simplify 1/3 because my denominator is my numerator, is a 1. 1 is the lowest that my numerator can be, and since it's already the lowest, it's already simplified. It's in its simplest form. So let's move on to the next one. I'm going to set up my 2/3. Remember, your denominator tells us how many parts we need. My denominator is a 3, so I need a total of 3 parts for this one. My numerator tells me how many parts I will be using or shading in, so I'm going to shade in 2 of those. 1, 2 out of 3. Then let's set up our next fraction. My next fraction is 1/4. I should have a total of 4 parts. My numerator tells me how many to shade in, or how many is being used. So 1. Then I want to go the opposite way and use the opposite denominator. So here I use 3. Now I'm going to use 4 with it and go the opposite direction. So I'm going to go ahead and go left to right and cut it into 4 parts. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my denominator for the other one should also be 12. My denominator here is 4. I'm going to use the opposite denominator and go the opposite direction. So I'm going to cut this one into thirds, going left to right. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So my denominators both ended up being 12. My numerator here, I have a total of 8 shaded in. So my numerator will be 8. And for the next one, I have a total of 3 shaded in. So my numerator will be 3. Remember that your denominator is how many parts you have. Your numerator is going to be how many parts you are using or shading in. So now I can add these together. My denominator stays 12. I take 8 plus 3, which is 11. So 11 out of 12. I cannot simplify this one because they are one away from each other. But if you do not catch that, then you will need to try to set it up and simplify it. All right, the next one, I want you to go ahead and attempt it. So pause the video, set up your models, shade everything in that needs to be shaded in. So hopefully you pause the video. It should be that you create your model. My first fraction, 2/5. I have 5 parts. My parts aren't exactly equal here. It's not going to be necessarily perfect. But make sure that you have 1, 2, 3, 4, 5 parts. Always count it because you might end up with 1 too many or 1 not enough. 1 less than what you need, I guess, to say. I need a total of 2 shaded in. So 1, 2. Now I'm going to do the other fraction, which is 2/3. You should have made a total of 3 parts because your denominator is 3. And you should have shaded in 2 of those 3 parts because your numerator is 2. Then you should have came back over and gone the opposite direction. Since my denominator is 5 here, I'm going to use the 3 from the other one, and I'm going to go left to right and cut it into 3 parts. If I count, I have 1, 2, 3, 4, 5, 6 shaded in, 7, 8, 9, 10, 11, 12, 13, 14, 15, which means my denominator should be 15 for my other fraction as well. If they are not the same, you've made a mistake somewhere. My denominator here is 3, so I'm going to use the opposite denominator, which is 5, and go the opposite direction. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I would have checked yourself and made sure those denominators are the same. They are both 15. If you made a mistake here, just check to see what it is that you did wrong, because that's where you're going to be making a mistake at homework so that you understand what it is that you need to do to add and subtract these. So now my denominator will stay 15. I will take 6 plus 10 and add those together, and I get 16. So let's talk about this really quick. I have 16 out of 15. My numerator cannot be bigger than my denominator. It is, so this is called an improper fraction, and I need to change that improper fraction to a mixed number. Now, on the computer when you're doing your work, I'm not 100% sure. They might leave it. I believe that we've changed them, but I'll always double check your answers. They should both be in there, I believe. But we do want to change this improper fraction. I refer to it as a snowman. If you're thinking about a snowman, the bottom of your snowman is bigger than the top. If it was the opposite way, I bet your snowman would kind of fall over. He's not going to stay up. So your top needs to be smaller than your bottom. Your numerator needs to be smaller than your denominator. We are going to take this and we are going to divide it. So this is where, and I've talked about it before, that you will learn how to turn your your remainder into a fraction. So my numerator, which is the top number, goes on the inside, that is 16. And my denominator comes on the outside, which is 15. I can only make one group of 15 out of 16. When I subtract that, I get a total of 1. So I would come here and ask you, how many whole groups did you make? Your quotient is your whole groups. So we made a total of 1 whole group. Then I would say to look at your fraction and see what your denominator is. Your denominator was 15. So we also used this number. My remainder will now become my numerator. So we end up using all three numbers, my quotient, my divisor, and my remainder to make my to make my mixed number. So again, the way that I like to do that is I set up the division, then I say how many whole groups did we make? We made one whole group. My denominator was 15, so it stays 15. My remainder goes on top. So we would say this as 1 and 1/15. All right, one more example. Sometimes your denominators are going to be a little bit big. So make sure, that's why I said, make sure you're kind of making your models kind of big. On your homework, if you need more paper, get that. Do make sure that you are making your models. It is important here because I'm not necessarily teaching you how to do it the other way. Your homework is also going to tell you to draw models. So even though I am not there, make sure you are drawing your models. When I get back and I go to grade this homework, I'm going to be looking for your work. So if you had no work and you turned in that homework, then I'm giving it back to you to redo. And when I look for your work, if you did not do the models, I'm going to hand it back and I'm going to have you redo it. This is in the instructions for us to use the models. It'll tell you to draw a rectangular fraction model to find the sum. So you do need to make sure we're following the directions. Eventually we leave the models and you can solve it however you want. If you want to use the models, use the models. If you just want to use the computation, use the computation. But today and every day that they are seeing drawing a model, we are using those models. So again, I will be looking for that. And this is one thing I'm going to be looking for on your next test. Again, we have another test next week, so pay attention. So this one is 2/7. So I have a total of 7 parts because my denominator is 7. I like to come here and I like to count as I do it so I can cut and say now I've got 1, 2. I've got 2 parts. I cut and I've got 3, 4, in which I'm cutting 1, 2, 3. I'm counting this as 4. So I now have 4 parts. When I cut again, I have 5 parts. When I cut again, I have 6 parts. So I need to cut another time, which is 7 parts. My numerator is 2. So I'm going to shade in 2 of those parts. Then we'll make the next one. I need a total of 3 parts. Don't make this one small because you think, oh, we only need 3 parts because we're going to be using that 7 again. So I'm going to cut that into 3 parts. For my 2/3, I'm going to shade in 2 of those parts. 1, 2. Then let's go the opposite direction. So this was a 7, so I'm going to use my 3 and go left to right and cut it into 3 parts. So now I have 1, 2, 3, 4, 5, 6 shaded in. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I can also think of this as 7 times 3 is 21. That's what's happening with my denominator. So on the other one here, I need to go left to right 7 parts. So there's 2, 3, 4, 5, 7. So 1, 2, 3, 4, 5. Oh, that was not 7. Let's cut in another one. So that's 7. 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 for my numerator. My denominator should be 21. We're still going to check it. 15, 16, 17, 18, 19, 20, 21. Again, 7 times 3 is what is happening. When you add it, you keep your denominator. 14 plus 6 is going to be 20, so I get 20 out of 21. They're only one away from each other, so they are simplified already. So a total of 20 out of 21. I can also come here and check and say I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, where did I make a mistake at? First off, that needs to be shaded in all the way. Okay. No, that's right, 20. I'm thinking of the denominator. So I have a total, if I count all of them, I have a total of 20 that are shaded in completely, which will match my numerator.